Bismillah ar-Rahman ar-Rahim. This is a paper, October 2024, 43 variant and complete mechanics paper. We are going to start. So get ready. Question number one. Question number one, question number one we have? An athlete has a mass and best technique of the mechanics full read and write. Mechanics M, so I'm writing M kilograms. Done. Athlete runs on a horizontal straight road against constant friction, and friction is what here? Small f. Okay, is given here 24 newtons. Okay. All right. And the total work done by athlete in increasing speed from 5 to 6. It means starting U is speed is 5 and final speed is 6 and distance 50 meters. And the work done by the athlete is 1541. So work done by this athlete is 1541 joules. So what to find mass? And we have a special formula. We use it. Work done by applied force, work done by frictional force, kinetic energy plus potential energy at an end point minus kinetic plus potential energy at a starting point. I call as a magic formula. So where's ending, end point, and there's a starting point. But do you know he's moving horizontally? It's a horizontal straight road, not inclined. Not inclined, so potential energy at this point and potential energy at this point will be equals to each other because the negative sign in the middle, so they will cancel out. So we will not waste our time in finding this. And this is 1541. We have already, and it is a friction force into distance, friction force and distance. So I will multiply them 24 times 250. Kinetic energy at end point means I will use this half m6 square, half into m u is what? 5 square. So I think clear. So I will take m common from here, and these values I will just solve it. So 36 divided by 2, I get 18. 25 by 2, I get okay, I can write it. So I got it 36 by 2 and 25 by 2. And here, so I can type it and I check it what answers turn to be. 36 divided by 2 minus 25 divided by 2. And I got it 11 by 2 mass. Okay, right, left hand side 1541, 24 into 50. I got 341 comes here. And into 2 divided by 11. And I got mass becomes 62 kilograms. So Alhamdulillah, Rabbil Alameen, I hope so. The concept is very clear. And let's go for next question. Question number 2, we have, so 3 forces are given, 16, 12, 24. So 4 forces. So 1, 2, 3, 4. And you're asking find magnitude, direction of a single additional force acting on a same point, which will be produce equilibrium. So first of all, students, I will find out how we can do it, resolve forces. So I will resolve this. Okay, and this. Okay, if you want to use this 30, no problem at all. All right, okay. Or out of 90 degrees, subtract 30, we got this 60. So you use 60 or 30, no problem at all, same answer. Okay, but I'm using as usual 30. So where angle given, that force and is a cos component. So 12 cos 30 and the 12 sine 30. Same way we have here one force acting parallel to x-axis and one parallel to y-axis, and 30 is acting here. So 8 cos 30 and 8 sine 30. And let's talk about the other one. There's a 30 here, and this I can write 16 cos 30 and 16 sine 30. Okay, now I can make it, what is a Rx? Rx is a force acting along x component. So So this is no component. It has a no component, 24 as it is, plus 12 sine 30 comes from here, and 8 cos 30, because all acting right side, they are adding up. But this acting left side, so negative. So subtract. So, and if I type this in calculator, so 24 plus 6 and plus 8 times 2 cos 30 minus 16 times 2 cos 30. And my answer is going to be 30 minus 4 root 3. Okay, better to leave as it is, or you can write it 23.0718 newtons. Okay, now students, I talk about a y component. This acting upwards, this acting downward is downwards. And it has a no y component, make sure. So I am going for ry. So I'm getting 12 cos 30 plus 8 sine 30. Sorry, not plus, minus. Reason, because this acting downwards, both downwards. So negative 16 sine 30. And if you type in calculator, times 12 times 2 cos 30 minus 4 and minus 8. And I got it. This is coming with me exact form, minus 12 plus 6 root 3. And in decimal format, I'm getting here, students, negative 1.6077 newtons Ry. So now, student, I will make a tape. I make a one cross, make sure positive and this negative. So positive means rightwards and negative means downwards. So I got a triangle like this, and this is 23.0718, and this is a negative 1.6077. So how to get this R? Pythagoras theorem, I will use it. R to power 2, 23.0718 power 2 and 1.06077 power 2. And take a root of this. And let me finalize 0718 square and take a root of this. And I got a 23.1. And now this angle I'm looking for, I will use tan inverse, okay, opposite by adjacent. And no need of using the negative angle, negative sign. Will give us theta. And when I type in a calculator, it's giving me 3.99 degree. Or we can say this is coming 4 degree. So two way of writing answer. So we can say 4 degree clockwise from x-axis. Look at here. So this is called direction. How to answer, students? Direction is 4 degree. 4 degree clockwise with x-axis. With x-axis, okay. Or second option, what is the right? But another way. This is the other way. 360 minus that. So the second direction, and we can reply is 360 minus 4. And when at 360 minus 4, I got 356 degree. And then just write with x-axis. With x-axis. That's it. Okay. So both answers are correct. You can write anyone, no problem at all. And I hope so. The concept is very clear. And let's go for question number 3. We have now car of mass 1600 kilogram travels up a slope of angle given here, and the horizontal, there's a constant friction force of this. Best technique, read and write. So mass 1600 kilogram. Okay, and if I count this is a theta, so theta is equals to sine inverse 0.08. If I bring sine on this side, it turns to be sine theta equal to 0.08. Okay, so this is done as well. and friction force is given 240 newtons. You can see friction force. It is given that car travels constant speed. Constant speed is understood. Speed is 32 and constant, so acceleration is 100% zero. And we need to find out the power. This is data writing is very, very important. It helps to solve a question. And now let's try to do it. And first of all, we'll take a okay. And all right. So we look here. This is theta, and the particle is this, let's say, and this is applied force, and naturally friction is downwards, and weight component is mg. What is m? 1600. What is g? 10. So 1600 times to 10 into sine theta, and sine theta value is 0.08. Okay. Now, what is a basic rule we have it? We have net force is equals to ma. And because system is going upwards, motion is upwards, so this force is bigger. And we always start from bigger force. And this both are acting downwards and both are negative. So capital F minus small f minus 1600 into 10 into 0.08 and equal to 0 because mass is 0, acceleration is 0. And you know, a power formula is F into V. If I bring the speed down, so F formula is power by V. So this formula I'm going to use here. So power by V is 32. Simply plug in the all numbers. And these two values, because negative sign, I will bring on the other side. So F is 240 become positive. And if I type this whole in calculator, 1600, one more zero into 0.08, it tends to be 1280. This whole thing is 1280. And if I add 240 and times 232, it's give us power is equals to 48640 joules. Watts. Okay, so I think this part is very clear. So first part is done. Okay, second part, he said find the acceleration of car when speed is 24 and the engine is working with 95% of the power found in a previous part. So it means this I will consider as 100%. So I'm writing here percentage and here power. 100% is equal to 48640, and I want to find 95% equals to how much power? P1 cross multiply. If I find it, and I'm finding by the calculator into 95 divided by 100, and I'm getting here power 1 is 46208 watts. Okay. So now situation is same. Again, I will take it. Same diagram and even same formula. Okay. And I copy and paste, or no need of copy paste. I can use directly from here. And basic formula is same net force equals to ma. So as we know, F is watt. I'll use directly this formula. Okay. And power by V minus friction minus 1600 into gravity 10 into 0.08 into mass into acceleration. Mass is this 1600 and acceleration is my target to find. And power is now, we can plug in this value here. We have all values 46208 divided by speed is 24. Okay, and friction is, you know, it is given 240. So 240. And this is, as you know, we can type, and I got a 1280. No need to waste time. 1280. And 1600 time to acceleration. So I will type whole in calculator divided by 1600 And if I check it, this is turned to be, let me check in calculator. So it turns to be 0.253 meter per second square. So alhamdulillahi rabbil alameen. I think the point is very clear and we have done it. This question as well. So question number 3 is completely over, and now we can go for question number 4. Question number 4 we have, and question number 4, two particles A and B is mass is 3 and 6 kilogram, line smooth horizontal table, so friction is equals to 0. Initially B is at rest, so B is at rest. You can see B is at rest, so velocity is B. Okay. A is moving with speed of 8, and AB after collide, A move with speed of 2. So it means we have to talk about before collision, after collision plan. So have a look how we can plan. This is a particle 1, okay, and particle 2, and both, okay, all right. And what is the particle A? This 3 kilograms. B is 636, A and B. And A is traveling towards B, speed of 8. Speed of 8. And this is 0 speed it has. Okay, it's not going anywhere. Whereas this moving with because he said 6-mark question, he said create us 2 possible values. So one, students, if a lighter particle hit with a object, so maybe there are 2 possibilities. Either both will go there, or one possibility, this will go there, but this will return back. It depends upon the masses and it depends upon the speeds. That is why. So we will take 2 situations, first this and then this. So let's start. First, I plan the speed is this of 2 after collision. And this speed I want to find. So this is before and this is after. This diagram is very important. A formula, you know it very well. M1 U1 plus M2 U2 is equals to M1 V1 plus M2 V2. Mass and V, so this 3 into 8, and this is 0, so no need to write it. I'm saving my time. So 3 8s are 24, 24. 3 8s are 24 plus 0, and equals to 3 2s are 6. So 6 and 6V. This goes there, and I got a 18. 18 divided by 6, we got a 3 meter per second. So this is a one option. So we got a first situation when we got a 3. Now we have a second situation. This is a situation if they are traveling in a same direction. Now let's talk about if it rebounces. So what is the best way of, I'll copy whole thing up till here. So copy and paste. Okay, this situation number 2, I'm going to finalize. Okay, but only one thing to change. This arrow, reverse. Bounce back. Rest everything same. So again, this is 24, again this is 0, but this time for your knowledge, whenever observer's eye is here, basically what criteria we have, let me tell you one very basic idea. When particle going away from observer, velocity positive, coming back, velocity negative. This is going away positive, this is going positive, but this is negative. So I will write it 3 8s are 24. Here no change, here 0, but here I write 3 2s are 6, but speed is negative, so 3 times 2 negative 2. Here is 6V. So when negative 6 goes there, we got a 30, and 6 divides, and finally I got a 5 meter per second. So I believe this part is very clear. So we have 2 possibilities, And now he's demanding from us find the greater. It means there are two possible kinetic energy losses. And he said, which bigger loss? Find that only. And though I can guess easily, for example, if this is a, this before collision is this. So let's find it. I can do for situation number one, though we can do directly also, but just sake of your understanding. So condition case number one, I do it. So kinetic energy before collision. So half mv square. What is the mass? Mass is 3 and 8. Half mv square. So this is becoming 9 into 8 and divided by 2. And we got a 36. Sorry, was it 1/2? Okay, 96. Because half into, mv square. Sorry for that. I have to plug in this power speed here. Okay, I'm getting answer 96 joules. Okay, this before collision for the both cases. Okay, but kinetic energy after collision, after case number one. So we have you can see after collision, we have this speed and this speed, we have it. So speed is 2 and speed is 3 for the second particle. Half mv square mv. What is v? 2 square. Half mv square and mv square. 2 square. Let me check. Correct. And have mv square. So 6 into 3 square. Okay, if I find this one, students, I get it what here? I get it here. Let me check. So this is becoming 6 plus 27. I got a 33 joules. And what's the loss? So loss is obviously the difference. So 96 plus 33. So it means I got a 63 joules loss. So this is the first 63 joule loss. Condition number 2 and case number 2. Okay, kinetic energy after collision. After collision, before remains same for the both cases. So I will not waste your time. And after what we have this. This is simple, but speed is the second condition is a 5. So half into mv square plus half into m5 square. And this will give us what, if we check it in calculator, it is give us 81 joules. And then what is the loss? So loss becomes, large loss is becoming, if 96 minus 81 is giving us 15 joules. So greater, what do you talk about? You talk about greater. So greater loss. So greater loss of kinetic energy is equals to, greater loss is 63 joules. So I hope so the point is very clear. So we can do without even, because we know this. This value become bigger, so loss becomes smaller. I can stop even here because this is a small, this is a value small, so loss is a bigger. So I can stop even here, but just sake of your understanding, I explained to you. I hope so the concept is very clear. Let's go for next question. Question number 5. Particle of mass 12 kilogram is going to be pulled across the horizontal plane. Okay, the string is angle 30 degree, you can see here. And he said tension T, force is applicable, and coefficient of friction is given 0.5. Given that particle is a point of moving means it is about to move, or point of moving, acceleration for sure 0. So particle is not in motion. How to do this kind of question? First of all, mass is 12 kilograms. So this is into 10. So 120 newtons. And friction will be act backwards, very clear. It has a 2 components. It is one acting right parallel to x-axis. So this would be t cos 30. And this would be naturally t sine 30. Okay, now this is R, naturally, normal reaction of any particle placed on the horizontal track. Okay, so now we can find it easily. What's R component? These two forces acting upward is downwards. I can say here R plus T sine 30 is equals to 120. And sine 30 is half, so this is a T by 2. And R, I got 120 negative T divided by 2. How I got 2? Because sine 30 is half. But mu is given by him, coefficient friction is a 0.5, and I can find mu F is equals to mu R, and mu is 0.5. I can say half, and R is 120 minus T over 2. So this goes inside, and friction becomes 60 minus T over 4. So this is a friction force, I got it. Okay, which remains same throughout if the particle is not changed and if this angle is not changed. Make sure if angle change, then this will change. Okay, let's see what he's saying. Naturally, system is we can say net force is equals to ma. Okay, rightward force minus leftward force equals to 0. T cos 30 and minus friction is equal to 0. Logic, because about to move. Okay, and I bring friction on the other end, so T cos 30, and cos 30 is root 3 by 2. You can keep as it is or plug in the value, and F is 60 minus T over 4, because this F value comes here. Now, because there are two T's involved, I'll bring this T on this end. So this becomes root 3 by 2T plus T by 4 equal to 60. What is common from here? T common, root 3 divided by 2 plus 1 over 4, 60. So when it divides, so it will turn to be this form. So I hope so this is very clear. Why I'm doing this way? Sometime he asks you for exact value. So this is give you exact value if you complete here, or if you type in calculator, it will give you the answer, and the answer turned to be 53.8 newtons. I hope so you got a point. Very clear. First part is finally done. Okay, so let's talk about the next part. Instead, the particle is accelerating in point 2. So it means situation is same because he did not change the angle. He did not change anything. This is a angle remains same. So R same, everything same, and surface is same. So everything is same. So it means I will take a same situation, same, I will take a data, but on not is equal to 0. Make sure. So I copy and I paste. Okay, make sure this is this is not equal to 0. It is a mass into acceleration. How much mass given by him? 12 kilogram. 12 kilogram, and acceleration is 0.2. Okay, students, so T cos 30, I can bring friction value from top. This as it is, no change. And here root 3 by 2, because cos 30, as I said before. Okay, and minus friction value in the bracket 60 minus T over 4 equal to, this is a 20, 12 times 2.2, it gives us 2.4. Okay, now this open the bracket, so root 3 by 2 times 2T, and negative 60 plus T over 4 is equal to 2.4. This 60 will go on the other end, and TT common out, and I get a what situation? Root 3 by 2 and plus 1 over 4 equal to 62.4. And when it divides, it will look like this format. And if sometime he asks you exact value, we can do some more calculation and over. But this particular situation, he never asked for exact value. He's not asking, sorry, here, not never. So if I type in calculator, I'm getting 55.9 newtons. I believe the point is very clear. So let's go for next question. Next question is number 6. A particle moves in straight line. It starts from rest. Okay, very clear. When time is 0. Okay, and acceleration is given by him a formula 0.6 t. So acceleration is 0.6 t. And for 4 seconds, it accelerates. Okay, reaching speed of v. All right. The particle then travel with the speed of 11 afterwards. Okay, after reaching there, then it continues same speed, same straight line. We have a parallel to x-axis, and for 11 seconds, and finally slows down with the constant deceleration. It becomes further 5 seconds. So we have to show this velocity is 4.8. Basically, students, we have acceleration 0.6t. Okay, and we have three situations. Let me show you three levels. We have displacement, and next level I got velocity, next level is acceleration. If you differentiate, I get it velocity. If you differentiate velocity, you get acceleration. If I want to come down in reverse process integration and acceleration integration, you get a velocity, and again integration, you will get a distance or displacement. Okay, currently I am on the level of acceleration and I'm looking for velocity, so I will not go for differentiation. No, I will go for integration. So when I integrate this both sides, I will get here velocity, because you can see that acceleration become velocity. Integral sign 0.6t and dt. According to situation, increase the power by 1. What is the power? Nothing is 1. So 2 by 2 and plus c. And this becomes, and he said when time is 0, it is a rest. It means I can plug in when time is 0, velocity is 0. When I plug in this here, 0.3 into 0 plus c, so c will become here 0. I plug in back an equation, velocity turns to be 0.3 t to power 2. But he said prove it when time is 4 seconds. So I will plug in 4 seconds. So put t is equal to 4. And when I plug in 4 seconds, because I want to find the 4, so 16 into 0.3 becomes 4.8 meter per second. So proved. So alhamdulillah rabbil alameen, I believe this point is very clear. He's asking sketching here, very interesting part. Many students confuse here. Okay, and I just tell you the two ways I try to express you. First of all, velocity expression. I can take a look here. I can take a look here, but sometimes students not understanding how to do with that. Or you can check this one. So students, because time is 4, starting from rest. So I will just plug in calculator some rough values. If I plug in 0, if I plug in 1, if I plug in 2, if I plug in 3, if I plug in 4, you see this, what is happening. So we have two possibilities. Students confuse here. So either we have this part of graph, or we have this part of graph. Okay, so let me tell you one thing. If we have this kind of graph, first, it is a bigger acceleration, then little smaller acceleration is decreasing. Okay, but when we have a other graph, this kind of graph, so then at this value is less acceleration, here bigger gradient, so more acceleration, bigger, more acceleration. So let's see with the 0 and 1, 2, 3, 4, is acceleration increasing or decreasing? When I plug in 0 here, I get acceleration is 0. When I plug in 1 there, I get a 0.6. When I plug in 2 there, I get a 1.2. Oh, okay. It means acceleration is increasing. So this is not a right choice, it's a right choice. So we got it how easily that acceleration, because acceleration is a gradient. So we understood that we have this special kind of, though it's a sketching, but still, I suggest you make a close to accurate. Okay, close to accurate. Wait a minute. So I make a line here, this. Okay, and I'll make a line here, this. Okay, now remove the scale and check it. Common sense. He said that when time is 4, speed is 4.8. So, and 4.8. So I take it this 1, just sake of understanding, 2, 3, 4, 5. So 4.8 is somewhere here. And what's the total time he talk about? First 4 seconds, 4 plus 11, 15, 15 plus 5, 20, 20, 20. So I make it here 20, how it possible? 1, 2, 3, 4, 5. So 1 minute. 5. So 2, 4, 6, 8, 10. Then 12, 14, 16, 18, 20. I think just take a easy to make it, because sketch, this is not important to show all values. Okay, here I'm writing, this is a seconds, time in seconds. And here meter per second, velocity. Okay, so now students, let's start. As I said before, when time is 4, 4.8, 4.8 is here, and 4 is here. So look at here, 4 and 4.8. So I have this kind of graph. So this is a wrong. Why wrong? It is a decelerating. It is a decelerating. Okay, so this is not a right choice. This is accelerating. How I know that, I explain again. When I plug in T1, T2, T3, T4, is rising the air, and this is a gradient in velocity time graph is representing acceleration. So then in 4 plus 11, plus 4 plus 11, so 15 till 15 is here. So go up, stop here. So it means I will take a scale, and till 15 I will make a straight line. Okay, let me check. Yeah, because rough. Okay, and then I will take a scale again, and he said it's directly meet with the join with the first constant deceleration. And I hope so the point is very clear, and sketching part is done. Stop further 5 seconds. Okay, and he said here constant deceleration. So I think this part is very clear, and let's talk about the next page. He said find expression of the time, expression for the time for the velocity for the last 5 seconds. So I think I will go back, and better to show there. Okay, he talk about this equation of line, how to get it. Equation of line formula, you have done it in lower grades. Y is equals to mx plus c. Current situation, this is v, so v is equals to m times to t plus c, because t along x-axis. Okay, now first of all, I'm looking for the gradient. And what is this coordinate? X is 15, y is 4.8. X is 15 and y is 4.8. Here x is 20, y is 0. So what is the gradient formula? Is a y2 minus y1 over x2 minus x1. So 4.8 divided by 5, I get it here. Negative 0. Negative 0.96. Negative 0.96. Okay, this I got it now, students. So this, this will come directly here. But C is missing, so I will plug in this M here. But same time, I can use this data or that data to get a C. I use this one. So this comes here. So 0 is equals to negative 0.96 times to 20 plus C. And if I multiply by 20, I get it here 19.2. So C value 19.2. If I plug in back, so final equation is M is this and C is this, and that is our final answer. I hope so you got it very well. Or you can use the other formula, and that is a y minus y1 equals to m times 2 x minus x1. And x1, y1 could be this or that, and m is this one. So no problem at all. I hope so the point is clear. And let's go for next part. And next part is what he's asking here. Find the total distance travel. And how to find that one? If you go back and see the situation, so you can see here, this is a area under curve, and then this is a rectangle, and this is a triangle. So for last two part, nothing hard. First part, you just integrate, because I discussed when you velocity and you want to go distance, so you have to integrate. But which equation? This equation. So 0.3 t square, 0.3 t square. So distance turns to be 0.3 t square dt and 0 to 4. And then we have length time to width and last triangle half into base into height. Okay, zero. What's increasing power by 1 divided by same, and I got 0 to 4. And here length into width, go back and check the values. So not a hard job. This is 11, as he said, 11 seconds. Okay, and this is actually 4.8. So this is becoming 11 times 2, 4.8. Okay, done. How to find half into base into height? Base is a 5 seconds, and height is a 4.8 second. If you don't, no idea, go back and show you this triangle I talk about. Sorry, this triangle I've talked about. This gap is 5, and this is 4.8. So I hope so this point is very clear, and we are going to finish the question. Okay, students, so have a look here now. I think this is becoming 0.1 t to power 3 and 0 to 4 limit. And here I just 11 times to 4.8. I'm getting 52.8. Okay, and half into 4.8 into 5, I'm getting 12. Here, upper limit minus lower limit, I get 0.1 into 4 to power 3. I got a 6.4 plus 52.8 plus 12. If I add 52.8 and plus 12, I get the answer 71.2 seconds. Sorry, meters. So Alhamdulillah Rabbil Alameen. So total distance travel is 71.2 meters. So in this question, student, the main problem is a diagram and the differentiation integration criteria. So let's go for question number 7. Question number 7 is what we have. Two particles A, B, mass 3 and 5 kilogram. You can see here, and connected, okay, 3 and 5. Okay, so first he asking, this is a 1 meter height, and this is a, you can see clearly 2 meters height. Okay, the data is very clear. And he said that release from rest, so starting velocity 0 for both particles, and A does not reach the pulley and B reach the plane is very clear. We have to find out tension and the time to reach, okay, by B particle. B is a heavy particle. Okay, what is the weight component of this is 50 newtons, because 5 times to 10, 50. What is the weight of this is 3 times 10, 30 Newton. And tension remains always towards pulley. There's an obviously rule. Okay. And because it's a heavy particle, is a lighter particle, so this will fall down, this motion towards downwards, and this motion must be upwards. Good. Okay, this point is clear. So we go now for 2 equations. Let's talk about a B. And what is the basic criteria we use? Net force equals to MA. So 50 minus tension equals to MA. 50 minus tension. And what is the mass? 5 times 2 acceleration. Now, because this motion downward, so I started from here. Make sure from here. Okay, now because this motion upward, I will start from here, not from 30. Make sure. So A, I'm writing tension minus 30 is equals to MA. Now, students, I'm going to cancel this tensions, and I got here 30, and I got it 8. And acceleration becomes here 2.5 meter per second. Okay, though it's not asking us. And this 2.5, I'm going to plug in it here. When I plug in it here, let's see what happens then. So T minus 30 is equal to 3 times to 2.5. And 2.5 and this 30 will add. 2.5 is 7.5, into 3 times. Okay, and plus 30, it is turned to be 37.5. Alhamdulillah Rabbil Alameen. So this is our main task. But anyway, I got acceleration as well. And he asking, find the time taken for the B to reach the pulley, reach the ground. So let me give a title. This B is coming down, so down motion. So let's try to do it. And when we talk about this one, so starting is u0, distance it will travel is very obviously 2 meters to reach the ground, and time is our task. And acceleration, luckily I got it, so I'm using it there. So 2.5, and s is equal to ut plus half a t square, and s is 2 meters, u is 0, and acceleration is a 2.5, and t square. So this 2 multiplied there 4, and 4 divided by 2.5, and it becomes 6805, and take a root of that, and I get it here. I get it here in root form. I get 2 root of 10 over 5, and in decimals I'm getting here 1.2649, and rounding 3SF, you know the rule, so 1.26 seconds. But when I'll use this answer in next part, I will use exact, so for more accuracy. Okay, so this part is done, students, so let's go for next part. Next part on next page, he mentioned here, find the time taken. There's a find the time for A to reach at least 3.25 meter above the plane. So let's discuss. A is at least. It means this distance or more. Okay. So 3.25 meters. Keep your eye on 3.25 meters. Okay. Best technique, I just take this diagram and shift on the other page. Okay, and for a while I delete it. And this diagram, I'm going to, okay, I think I can use it there, 5, and this is 2 meters, this one. I can make on my own, no issue at all. So let's talk about this diagram. Diagram making is very important. Okay, students, so let's try to do it quickly. And this is hanging particle is B, and this is hanging particle A. Okay, and basically this is 1 meter distance, and this is 2 meter distance. 2 meters. Okay, so and what situation number next? If I make this idea, so B will go down, reach the ground. Okay, and this particle will go up, and reach here. So, and just before hitting, this is a, okay, I don't know the speed of that. Okay, the speed is very important. Actually, this is a 2 meter falling, and this is a 2 meter up. So I'm writing this arrow here. You can understand this is a 2 meters up, but I'm looking for 3.25. So this is a 3, and I need 0.25 more. So this is, let's say, this is distance is a 0.25, and this particle is here. Or I do one thing, slightly, I make this slightly up so you people can understand easily. All right, because we'll not reach the pulley. So this is a 3.25 from here to the ground, 3.25 meters. I think is okay. And this particle, when it comes here, he talk about that. So actually, he asking that how much it remains up. So this is a free fall upwards, how much it goes up and down. Okay, so this goes up and then comes down. So this is a whole story. So more, he said at least, so 3.25 and above. So actually, what is the planning? I want to find, first of all, what is the speed at this place, okay? And but before I need this speed, I need to find this speed, and this speed is same with this speed. So let's go for B just before hitting. I'm writing here just before hitting, you know, U0, and time I got in the previous page. If I show you again, 2 root 10 by 5. 2 root 10 by 5. 2 root 10 by 5 when it will reach down. Okay, and distance is 2 meters. I want to find last velocity, and s is equal to ut plus half at square. Okay, and acceleration we have as well, and that is actually this no need. We are using the other formula, and what that formula is 2as is equals to v squared minus u squared. And this time is even not required. I think I can use the easy one. V is equal to u plus at. Okay, that is easier way. That is easier way. So the v is a task, and acceleration is we have 2.5. Let me check 2.5 or what? Hold on. Yeah, 2.5. 2.5 is acceleration, so I use the same. So v is equal to u plus at. U is 0, acceleration is 2.5, and 2 root 10 over 5. So if I check it, multiply by 2.5, I'm getting root 10. Root 10. So meter per second. It means just before hitting, look, I show you students, this speed just before hitting root 10. And this speed is same like this speed. So this is root 10. For this is last speed root 10, and the last speed root 10. And this last velocity, this is root 10, will become for this starting velocity u10. So I'm erasing and I'm writing here u. So now I talk about the A particle free fall upwards. So A particle is a free fall upward, free fall up. Okay, and this V becomes U. Okay, and S is 0.25, as you can see from here. And gravity, you know, always free fall negative. So let's try to find it. And S is equal to ut plus half gt squared. So S is 0.25. Okay, and U is root 10. T, I don't know. Half times to 10 t square. This is sorry, this negative. This is a negative. Make sure there's a negative. Okay, negative. So this 5t squared goes there positive. 5t square. This goes there negative root 10t and plus 0.25 is equal to 0. Here, student, I'm going to apply quadratic formula. Okay, plus and minus b square and 4ac. Okay, by 2a. Here I'm getting 2 times, students. Let me check it in my calculator. Okay, first value outside is root 10, then plus inside we have a root, there's a 10, and minus 4 into 5 into 0.25 divided by 10. 2 5s are 10. And I'm getting, students, here, first time 0.53983 seconds. T1. Second time, I'm getting here, if I just change the sign outside, and I'm getting here, so 0.09262 seconds. Actually, I just tell you, when it gains, this is a time, you know, how much it will above going. Look at here. First time it reaching here, time is, this is the time for the first same height of 3.2. And second time it gains again height, the same height as 0.53. Basically, it goes up and come down same. So the first time 1 and the second time 2. If I subtract them, I come to know how much time it remains above the height of 3.25. So that is why both times I have to subtract. And let's see the time. The time is more, at least, okay, I can say subtract them, 0.53983 minus 0.09262. And let's see what answers turn to be. 0.53983, and I'm getting here 0.4472 seconds. So this is the time he was asking for. So I hope so. The point is very clear. All right. So this diagram make the question easier. Otherwise, it is very tough to understand. Anyway, and the paper is completely over. I hope so you understood very well. And those students who done some mistake, please, I request you reattempt after class, after this watching video. Best of luck for exam. Assalamu alaikum wa rahmatullahi wa barakatuh.